Hey guys, Greaves here. Let us take a look at review 20. Okay, so let's see. The situation is I got a ball on top of, it's a momentum problem with some linear motion stuff, right? So ball A is going to bump into B, head off the desk, etc. Right? Okay. So let's take a look. Calculate the speed of the 0.5 kilogram target ball immediately after the collision. Okay, target ball, right, after the collision. All right. So how am I going to get, I think they're talking about B, right? So how am I going to get the speed of B right after the collision? Well, it looks like I'm going to be using momentum, right? So what does the law of momentum say? Law of momentum says, right, outside, in an isolated system, total momentum of the system is conserved. So I have P before is equal to P after. So what do I have? I have two of the objects, A and B. B is at rest, so I just have the momentum of A, mv, is going to be equal to what? mv plus mv, where this is A and this is B after. Okay? Now they do give you some more information, right? They tell you after the collision that A bounces backwards, right? Bounces back the other way, right? And it gives you some speed, right? So let's take a look, right? So what do I have? Mass of the ball, 0.1. It was going 1.4 meters per second. That 0.1 afterwards is going to now bounce backwards. Remember, right? Velocity is a vector. So this has to be minus 0.7, right? Plus 0.5v. Okay? So this is how I calculate, right, the speed of that ball B. Right? So doing a little math here, I get something like 0.42 meters per second. So that's A. What about B? Okay, what does B say? All right, B says calculate, right? So we're given some information. Tabletop is 1.2 meters above the ground, etc. Calculate the horizontal displacement of the ball, of B, right? So let's take a look. Here is, right, my 1.2, right? I want to know what D is right there, okay? So it's going to go off like this. I think I know the speed now, which is 0.42. All right, so if I want to get this horizontal distance, it looks like I'm going to need the time. And guess what? I can get the time because I know how high vertically this is, right? So delta y is going to be v0t plus 1/2 a t squared. 1.2, 0 plus 1/2, 10 t squared. Doing a little bit of math here, I get a time of 0.49 seconds. Okay? All right, so now I know how long it's in the air. I know the speed that it's traveling, and I can say delta x is going to be equal to v0t plus 1/2 a t squared, which is the same exact equation, but I'm using this point right now. So it's going to be what? 0.42 times 0.49, and I got something like 0.2 meters. So I guess I'm 1.2 meters away. Okay, so that, right, is B. All right, C, right, we are changing things, right? I'm replacing B with C, right? And it's not going to hit straight on. It's going to kind of have it careen off at an angle, okay? So C shoots off in this direction here and lands at P, okay? Now they give you some more information here that you read through. And right, it tells you that I think the total distance here is 1.5, right? I think the height was exactly the same, right? So B, or I should say C, is now going to say calculate the speed of V, the target ball, immediately after the collision. All right, so how am I going to handle that? All right, so, right, I'm going to draw my table again, right? All right, so I know this is 1.2, which, by the way, if this is 1.2, I know the time in the air is 0.49, right? I do know that, right? And you're told that this is 0.15 meters, okay? So how far does this one land? Well, delta x is going to be equal to v0t plus 1/2 a t squared, right? This is just a linear motion problem. There's no acceleration, right? Because it's traveling horizontally. So 1.15 is equal to what? V0 times 0.49, right? So doing a little bit of division here, I get a velocity of what? 0.3 meters per second, right? So that's how fast, right, the C gets kind of pushed off, right? All right, so now what does the next one say? Calculate the y component of the ball, right? So the y component. So there's the ball, right? We know that it shoots off VC, right? So we know VC is what? 0.3 meters per second. We know that this is 30 degrees, right? So here would be my Vx. Here's going to be my Vy. So it wants to know, right? What is, right, this value right here, right? Okay, so Vy is going to be equal to what? Vy, let's say Vcy, my bad. Vc sine theta. So what do I have? 0.3 meters per second, sine of 30 degrees. I know sine of 33 degrees is a half, so 0.15 meters per second. So that's my Vcy. Okay, so that is that business right there. Okay, so that looks like 20, which is 20 in the first problem in 20. Let's take a look at 22, right? Second problem in 2 and 20. All right, looks like I'm going to have some momentum problem here, right? So I'm getting this cart collide with this cart. Now they're giving us some information here, right? They're giving us a force and time graph. All right, so please understand, what information can I get from a force and time graph? What I can get is the impulse. So what is impulse? Impulse really is my change in momentum, and I can get that by multiplying my force and time. So what happens is, this is the key to the problem, right? With the chart, finding out what the impulse is, and the impulse gives me the change in momentum that the cart is going to undergo, okay? So, reading this information, right, we're going to get a bunch of stuff, right? So, what do we want? Calculate the magnitude and direction of the velocity of the first cart after the collision. All right, so what happens is, we interact, right? Well, a couple things could happen. This guy could hit him, he could stop, that could go that way, they both could go that way, this guy can go backwards. So it wants to know, what is the speed of this cart after the collision? All right, so how am I going to get that, right? Let's take a look, right? So what do I got? I have this cart here. Here is, let's call, I don't know, there's cart, right? 2 kilograms. Going 3 meters per second this way. Here's some unknown mass. All right, so we're going to have an interaction, okay? So I'm looking at what happens after, right? So what can I find from my graph? Well, from my graph, I can get the impulse that this cart applies to this cart. So J is going to be equal to my delta P, which is going to be equal to my force times time. So really, what am I looking for? I'm looking for the area underneath this graph. All right, what type of shape do I have there? Well, it looks like I have a triangle. So the delta P is going to be equal to 1/2 force time. Okay, now be careful. They're giving me this as kilonewtons, 1,000. They're giving me this as milliseconds, 0.001, right? 100,000, correct? So what do I have? 1/2, 10 times 10 to the 3 times 1 times 10 to the minus 3. By the way, that goes away, right? So it's the 3 here, and the -3 kind of just goes away. 10 divided by 2 is 5. Looks like the impulse, right, or the change in momentum that this cart undergoes is 5 Newton seconds. Okay, let's use that to solve for the velocity and speed of this cart after the collision. Okay, now look, the impulse applied, right? This guy is going to imply an impulse to him, but this guy is also, by the way, this guy implies a 5 Newton second impulse to this cart. This cart applies a 5 Newton second impulse to this guy. Now, we're saying this way is positive. So this impulse here is positive, but this impulse here is negative. So how can I find the speed of this cart? Well, I can use delta P. It's going to be equal to P2 minus P1, where P1 is the momentum of this cart before. Delta P is the change of momentum, which we found by taking the area under the force and time graph. So what do I have? And that is a negative impulse. That impulse to this cart is negative, right? Because it's the cart, this unknown, to this guy, which is this way. So minus 5 Newton seconds is equal to P2 minus, well, what's my original momentum, right? MV, 6 Newton seconds. So I'm going to add 6. So it looks like P2, right, of this cart after P2 is going to be what? 1 Newton second, right? Right? So that's the momentum, and it's a positive momentum, right? So now we actually know the direction. We know it's to the right, but that's not what's being asked. It's being asked, what's the speed? So velocity is equal to, momentum is equal to mv. So what was the momentum? 1 is equal to, which is a positive 1, right? And I want the mass, and we know that it's going, no, we want the speed, right? So we know the mass is what? 2, my bad. So that's 2. We want the speed, so it looks like it's 0.5 meters per second. Which direction? Since it's positive, it's to the right. So that gives me the speed and the direction and speed of the cart after the collision. Okay, so B, calculate the mass, right, of the second cart. All right, mass of the second cart, P before is equal to P after. What do I have? Well, this guy has momentum. It crashes in. This guy doesn't have momentum. After the collision, both of these guys are now going to have momentum. So it's going to be P is equal to P plus P, mv, mv plus mv. Where this is the first cart, this is the unknown mass, right? So what do I have? 3 times 2 is 6. We know that this was what? 2 times 0.5 plus, we know that this is 1.6, right? 1.6, right? So we want m, and we know we're told that it's going 1.6 after. So doing a little bit of math there, we get a mass of like 3.1, right, kilograms, right? So that's that business right there. Okay, next stuff. Now, by the way, it's weird. This problem goes from all this momentum stuff right into linear motion now, okay? So what do we got next? All right, so second cart goes forward, it goes up a ramp, does a couple of things, and it's going to give us some information. So calculate the acceleration of the cart at 3 seconds. All right, so I want the acceleration right there. So I have a velocity versus time graph. How am I going to find the acceleration? If I have a velocity versus time graph, looks like I'm going to take the slope. And I know I want it right there, but the slope is constant throughout, so I'm just going to take the slope there, right? So what do I have? Slope, right, is equal to what? Change in y, change in x. So change in y, what do I have? 0.5, right? 1.1, right? So 0.5 minus 1.6, 1.6, right? Over what time? 3.5 minus 2. And I got something like minus 0.73 meters per second. So that is the acceleration of the cart as it goes up the ramp. D is saying, right, calculate the distance traveled by the cart during the whole time interval. All right, so if I want acceleration, I take slopes, right? If I want distances, I take area under the curves. So there's a couple ways you can do this. You can use equations. What I'm going to do is I'm going to break these up into different sections, right? So what do I have right here? I have section 1, area under the curve, right? So this is what I'm just going to give you numbers. 3.2. By the way, I have 2 shapes here, triangle, rectangle. I got 1.6. Adding both of those, here I just have a rectangle, 0.75. Adding those together, you get a distance of something real close to like 5.5 meters. Okay? Next, state whether the ramp goes up or down and calculate the maximum elevation. All right, well, my acceleration is what value? 0, right? I'm sorry, negative. So if it's negative, that means it's going up an incline and slowing down, right? So the ramp is going up, right? How about the maximum elevation? All right, how am I going to find anything, an elevation of something that's moving up an incline? It looks like I'm going to use energy, right? So what do I have? K is equal to what? Well, let's hold on a second. What do I got here? Here's the incline. What type of energy do I have here? All kinetic. But look what happened right here. I did go up the incline, but I still have what left over? Some kinetic. So in the beginning, it's just kinetic. When it's reached the top of the incline and continuing, it still has some kinetic and it has somewhat potential. So it looks like 1/2 mv squared. It's going to be 1/2 mv squared, and this is the where it is. It's reached the top of the incline, and it continues on plus mgh. Looks like I can get rid of that. Get rid of that. So 1/2 1.6 squared is equal to 1/2. How fast am I going here? 0.5 squared plus 10h. Right? So what do I got here? I think I did this, right? So let's do it, right? So 1.6 squared times 0.5 equals, so this is that right? 1.6 squared times 0.5. So this is 1.28, right? 0.5 squared times 0.5 equals, this is 0.125. So I'm getting 0.128 minus 0.125 equals, right, divided by 10. So, right, so I'm getting, divide that by 10. So I'm getting a height of about 0.12 meters. Okay, so there is number 20. All right, guys, see you later.